Alright, so now we're going to begin Module 2. Working walking surfaces, including fall protection, commonly referred to as slips, trips, and falls. Major issue in industry are slips, trips, and falls. So kick off with an example of an actual OSHA recordable fatal accident of an individual who was cleaning windows. The individual had a was it was discovered that they were possibly on the wrong side of the ladder, but they had a bucket full of water, uh, washing windows, somehow slipped, fell onto a tile floor, hit their head. Within a half an hour, they were pronounced dead at the hospital. Um, these things are accidents. Most of them are preventable. Uh, and that's the reason why we have this program, so you can think about things that you do it 100 times, but that 101st time may not necessarily work out in your favor. So you have to think about them on the front side to ensure that you don't accidentally become a statistic. So how big of a problem can it be? The majority of the accidents in general industry, 15% of all accidents or accidental deaths. I believe that is all accidental deaths across the spectrum. It's not just in the industrial environment. But that's a huge thing. It can happen at work. It can happen at home. So the point of these modules is to help you digress and gather information, come up with logical conclusions and solutions about problems that may exist. So during this particular module, we're going to be able to identify some hazards associated with those surfaces and possible best practices for mitigation. And then there are employer requirements which are listed in the CFR 29/1910, that big OSHA manual that I was telling you about, that is linked in Module 1, I believe it is. So you can look through those and look up some of these employer responsibilities. So, just give you a real quick overview here. I mean, they can happen anywhere. You have a greasy floor, oily diamond plate, worn out soles on your shoes. If you look at it, there's no tread left on that shoe. That shoe on that diamond plate is going to cause a huge issue. That is an absolute guarantee for a slip and possible injury. So, these things, you have to think about these things. So these are actual OSHA photographs, by the way, that were discovered during OSHA investigations. We have random pieces of wood stacked up on end, a busted floor, uneven walking surfaces. There actually looks like that's a gap. I can't tell if that's a step down or a gap. Either way, doesn't look safe, possibly quite dangerous. Should it be like that? No. Can it be fixed? Most likely, yes. An example, tripping hazards over hoses. In my machine shop, I have air hoses on my CNC machines here. I've been here for 8 years. The air hoses have been in the exact same spot for 8 years, right on the floor, in front of the machine. Nobody ever thought about it. I had a student over the summer walking around the machine, got his leg caught up in the air hose, and took a fall. Nobody ever thought that it was going to happen. You don't think that these things are going to happen. I have 8 new air hoses now that I'm going to be putting out on these machines, to prevent this from happening ever again. A cable, here's a cable strung across some water. I don't know what's going on there, but it looks like a trip hazard. We have pieces of material here, another possible trip hazards. So, things to look out for. So how do you control them? Well, a lot of this stuff is common sense. I understand that. But sometimes we just don't see it. The having proper walkways, having things that are well lit, identified, marked with aisles, having lines. Nothing can be inside these lines. Trip hazards, having transitions from working mats to the regular floor. Is the mat curled up? Can somebody easily walk by, trip on that, down they go? Hoses and cables. My example of the air hose in front of the machine. These are all potential accidents waiting to happen. The fall from elevated surfaces. We have an individual here climbing up a ladder. That is a really tall ladder, and I don't know about you, but I wouldn't want to do it. That is a big fall. We actually do see how this individual does have a fall restraint here. That's what that cable is. We're going to learn more about what that is. But these are times where it's going to be required to have fall protection. Here's a pit, an open pit that is, there's no railings around the pit. So, that there's an accident absolutely waiting to happen. You have possible structural collapse. If floors are, if the weight limits are exceeded, so you have 100 pounds per square foot over the course of the entire floor, you overload that, and it's possible for a structural collapse. I have a couple 100 pounds in the, I don't know what you call it, platform up above me right now. It is equally spaced out, but there's a limit up there, I believe about 50 pounds per square foot. So if we were to exceed that, the concrete floor and my ceiling could collapse. These are, things, I'm sitting directly below this stuff. So, things that you need to have in consideration. Controlling the fall hazards, that's obviously another thing. You guardrails, personal fall rest systems. Sometimes you need to climb up on these taller structures. If you're in an industrial facility, you have these tall structures that need to be climbed up. These are instances and these are times that you need to make sure that you have some way to mitigate your falling potential. And then when you're up top, the guardrails are required. We're going to cover the requirements for guardrails a little bit here in a minute. ABCs of hazard controls: anchoring, body harness, components. All right, you can't anchor. It has to be a good anchor. You can't anchor to something that is movable. In one of the optional videos, in an individual that you may or may not have watched, an individual was anchored off to a guardrail, and then the guy down he went. So these are things that need to be taken into consideration that are required to maintain the safetiness. Another example here, no guardrail. There's also no tow rail here. There's a potential for falling. Structural collapse. This is obviously a cartoon. Hopefully nobody would drive your fork truck across hardwood floors. But obviously we've exceeded the load limit. There should have been a sign that would prevent something like that from happening. Falls can happen at any height. Okay. Standing on the first rung of a ladder, potential for fall is there. As soon as your feet leave the ground, there's a potential to fall. If we look at this middle picture here, you can clearly see that doesn't look very safe. Here, possible tip over from a scissor lift. These stairs, that's a big no from me. Okay, so your different types of ladders that you can find in a manufacturing facility or any industrial facility. Step ladders are common. You see them all the time, trying to get something from the upper shelf or whatnot. Extension ladders, if you're working in home construction, electricians, even plumbers need to get on a roof or some thing. And then the fixed ladders, you know, with this case here, has a cage located around the ladder. The ladder is actually affixed to a structure. Now, I don't know the exact grandfathering clause on a lot of these, but I can tell you right now, I have a ladder to that area up above me that is fixed ladder, no cage, no fall protection system. Should there be something there? Yeah, probably. But nothing's ever gotten done to repair something like that. So, I don't know about you. There have been times where I've almost fallen off a ladder. You have to understand how to use ladders properly, using the right ladder. Ladders are free from defects. If you know it's missing a step, if it's if the wood, if it's a wood ladder and the wood's all dry rotted out on it, if the aluminum ladder is all bent out of shape, you know, using the ladder properly. This ladder is designed to be opened up like that. It's not meant to be leaned up against something. That is not how it's designed. So things to take in consideration. The other thing is that you'll see it on all ladders. They tell you never use the top two steps of a ladder. The reason being is when you're standing with the top two steps above you, you can lean against something. When you're standing on this tiny little area up here, there is that major potential for falling off of the ladder. Use the right ladder for the job. If not, you have to figure out another way to do it. Don't do like the guy did in the video and put a ladder on top of a table on top of a picnic table. I don't think I would have even done that. So, you know, do things that are correctly. Right here it says, tell your supervisor if you need a longer ladder. Don't do the job. If it's possible dangerous, don't do it. Don't use a bent leg ladder. You know, proper use. The number one thing you can do is use them according to the manufacturer. Now, I forgot to mention this neat looking little star up here in the upper right hand corner of this part here. I think there's maybe about 5 or 6 stars. That's kind of neat. But make sure that you're following the informational stickers and warning labels. Look at that. Look at that star. 3 points of contact. You've heard it before. Make sure you're maintaining 3 points of contact on your ladders. Don't do this. Okay? That's not 3 points of contact. You can easily lose your balance. Think about it. If you need to do something like that, you're using the incorrect equipment. You need to figure out how to do it properly. You twist your body like that, not only is it bad ergonomics, it's a possibility for a potential. There's that star again. Using ladder. This is an actual OSHA requirement. If you are going from one level to another, ladders must extend 3 feet above the landing point. Okay, coincidentally, that's also about the same height as a railing. The reason being is that when you climb up, you have something to hold on to. Cages. The fall arrest system installed after 2018, and the cage or the well if installed before 2018. Like I said, I don't have a cage or a well here. Maybe they just deemed it that it's not high enough. I honestly don't know. It's been there for probably about 60 years, just like that. So that cage, though, it's not really super safe. I mean, if you fall, you're just going to bounce off the cage as you go down. Fall arrest system, you fall, it'll catch you. You lower yourself down. So, you know, you have to figure out the safest way to do things. Scaffolding needs to have proper decking, properly set up. That is obviously unsafe. I wouldn't use it. You know, if you're dealing with unsafe equipment, you need to notify your supervisor, have these things straightened out. Make sure that everything are set up properly. Follow the user's instructions, the manufacturer's instructions on these. All of your platforms They need to be fully decked. They need to have guardrails. The railings, they have to have an easy way to access them. I mean, if that ladder's not there, how do you get up there? So, you should not be exposed to a fall hazard due to partial decking, meaning you have a couple of pieces of wood on there, but you have to jump from piece to piece. Okay, it needs to be a secured floor. Using your fall arrest system, it says here it needs to be provided on any scaffold that is 10 feet or more above a lower level. So, meaning if I had a scaffold out here, if I'm 10 foot above the level that I am on right now on that scaffolding, I need to have the guardrail or the fall arrest system. All right, safe access, obviously, if you don't have a ladder to get to it, you don't have safe access. Your employer is required to give you safe access to that platform. Don't go near power lines, okay? 10 feet away from power lines. And notice how it says 3 feet from insulated. I don't know if a lot of you knew this, but most power transmission lines are uninsulated. The ones that you see outside running among the streets and the high power lines, those are not insulated. If they're bare wire, so that's why that says that. 10 feet away from those power lines, or 3 feet from the insulated lines. 3 feet would be insulated lines that we have in here in the shop, in your manufacturing facility. Locking the wheels. These things will roll away from you. Yeah, common sense. No, think about it. If you're not locking the wheels, it can get bumped into and roll away. Guy comes up, leans up against your cart there. Next thing you know, off for a ride you go. Another star. The height of the platform must never exceed 4 times the minimum base dimension. So it's like a 4-to-1 ratio. Okay? So you have a base dimension, and the height can't exceed 4 times that. So you may have to do outriggers. The higher up you go, you need to be outriggered out to have your base bigger than your extension. Okay, it's a 4-to-1 ratio. Just looks like, 4 times the minimum base dimension, I think, is what you're looking to try to get out of this. Scissor lifts. I wouldn't go on a scissor lift. It's most injuries they occur. You're not having fall protection. You don't have the proper stabilization, positioned incorrectly. These things need to be perfectly level when you're setting them up. If they're not stable, if they're on unstable ground, if you don't have fall protection, you lean up against the railing and down you go. One of the statistics is that OSHA having 20 preventable injuries over the course of a year with accidents involving the scissor lift. So they can be dangerous. Having your fall protection on the scissor lift. Now, this one is missing my wonderful star. I don't know. I'm just guessing. I'm guessing at that. But one of the big things is the stability and positioning, but also wind. There was an individual at a Notre Dame football game that the wind was blowing so hard, knocked over the scissor lift. So OSHA has determined that a 28-mile-per-hour wind is about the max that you can safely use one of these scissor lifts. Little star, not there. I'll get a star on the one that I upload. All right, using stairs safely. Industrial facilities, they need to maintain 1,000-pound live load. Most of the stairs you're going to see are steel, 22 inches wide. you know, you can't have too steep. Now, those of you who've been on a Navy ship, I think those things are a little bit more than 50 degrees, but more like ladders. But they have to be at a safe angle. You cannot have some sort of extreme angle to try to access equipment. Those of you who may be involved in manufacturing, whether it be machining or industrial repair, you will see these industrial ladders located throughout your facility. They need to be safe for you to access the equipment that you're working on. You have minimum tread depths, minimum tread heights. These are actually requirements as far as home construction goes. So, you know, you need to maintain that safety, as having this hand railing here as well. Okay, stair railings are required when there's 4 or more risers. So, you know, and then when you have that height, then you also need the guardrail system. We saw this picture a little bit earlier. Those stairs need to be scrapped and replaced with something like that. High quality stairs. Don't jump the last few steps. We see it all the time. It's fun. People get hurt. So, you know, don't do it. Heavy objects, you know, don't be carrying several 5-gallon buckets down the stairs as you go. More hazards and controls, you know, having buckets on stairwells like that. The stairs are not wide like that, so you can store equipment on them. They need to go into their own shelving area. You see things like that, you need to clean them up. You need to put them where they belong. Open pits. Those need to be guarded all the way around. An individual walking by, nowadays looking at their phone as they're walking, fall into pits like this. If you remember from the videos that were optional, you see an individual opens up a pit, another individual falls into it. So, you know, these things do happen. If there's more than a 4-foot drop, they must be guarded. So we see here, we see tow guards, we see guardrails. On here we see more tow guards, tow boards, hand railings, little star there. The 42 inches, plus or minus 3 inches. Okay, so that's important. Your top rail needs to be at 42 inches, plus or minus 3 inches. That's kind of an industry standard. That is also listed within the CFR 1910. It's actually, and I'll give you the citation on that one because I'm looking at it, CFR 1910 29B1. When the PowerPoint's uploaded, you'll be able to actually click on those links and see those different areas there. So the last couple of slides are just some hazard recognitions. You're more than welcome to just look at them and see what you think the hazard would be. You can pause the video and say, I don't really like that. You can look at the pictures and see what's going on. Fall protection here. I don't even know what's going on in that picture. That's a door, I think. A pit. No fall protection. Silo ladder. Broken cage. No handrail. No tow board. Messed up stairs. Platform on mud. That's always a great idea. So anyway, this is the last one. Hopefully it wasn't too long, 24 minutes on that. So remember, discussion board. I don't know what the discussion board is going to be yet. By the time the video is posted, there will be on there. And the quiz. Go through the quiz, and that's about it. If you've grabbed my hints anytime during this video, you'll know what you need to be doing. So with that, give me any questions, email, or see me in class if you have me. And I'll see you in Module 3.